In this video, you will see a focus on debugging. As a teacher, you will naturally bring together many computational thinking strategies in your lessons. Once students are familiar with naming each of the computational thinking strategies, we encourage you to look for opportunities to bring them together. For example, in this video, there are also opportunities to identify pattern recognition.
We are going to use a new strategy which should be familiar with you if you play video games. Yes. Let me remind you of one thing. If you did code, I know a lot of you did code or Scratch,
yes.
And the people who make those video games, when they put in the code, you know that if they make one wrong click,
debugging time is gonna be.
Yeah, what do you know about debugging? Is that because you saw it here or because you just know?
I already knew.
Oh, well, tell me what you know.
Debugging is when you go back and solve the problem that happened and you fix it.
I love it. I love that you were looking here, but you used your own words. That was really good. In coding, one wrong move will shut down the whole thing you're trying to do, won't it?
Yes.
Yeah.
So that is why usually when you do coding, you have someone who's doing, the typing, but you usually have another set of eyes too. You've got your driver and your navigator, and the other set of eyes are looking to see, is everything right? Oh, there is the bug. There is the problem. How many times do you hand in something for math or otherwise, and you just do it and you turn it in? Be honest. Do you ever do that?
Yes.
How many times do I get work and I say, this makes no sense at all?
All the time.
Because people didn't re-look at it, right?
Yeah.
So when we do debugging, this right here, there's one thing I want to change here. It says finding and fixing mistakes to improve my work. You may not have any mistakes, but does that mean that you still don't look through it? No. I've already turned in my taxes and made a small error and then have them send it back. And I know the math, I just was in a hurry. So debugging is often something that the better you are at math, the more you have to do, because when you go fast, you might make a quick mistake. So debugging is something that we slow down to do. And the good thing about debugging is you often find out that it's not that you're not smart, it's just that there's some sort of mistake. So the first thing is the thing that you do for survival, not just in math class. What does this first bubble say? Can you all read it together because it's that important? Everybody, 1, 2, 3.
Does my answer make sense for this problem?
Yes. Does my answer make sense? And when you want to know if your answer makes sense, usually you should go back to read the question or what you're supposed to do, right? Remember I told you about the time I asked, what are they doing in the picture? And someone said corn, right? You want to check and see. Yes.
And you can check by doing different kinds of math to check your answer.
Oh, so you're saying redo it a different way?
Yeah.
Excellent. So that is a good strategy. How can I review my thinking or my strategy? That is a good suggestion. Daniel's idea really matched with this middle bubble. I can review my thinking by trying it another way. And
if you get the same answer, then it's right.
Very good. What changes can I make to improve my work? Well, that can come from rechecking it with a different strategy. It might come from looking with a partner and saying, well, I did this, how did you do it? Ruby, do you ever do that where you have your ideas, but then you need to run them over with somebody else and listen to how they did it?
Yeah.
That happens a lot. Do you think you do debugging when you do your writing?
Mm-hmm.
Yeah.
Right? We look for little things like commas and periods and spelling and things like that. So, yes.
That's why we do a drafts.
That's why you do a draft. Excellent. Yes.
And that's why we do the rating. I like rating, but it's a little hard.
You like writing, but it's a little hard. But it doesn't stop you from doing it, does it?
Yeah.
You can have all of the smarts in the world, and like Daniel said, sometimes random mistakes might happen. Do you also realize that when teachers ask you to show your work, I shouldn't say ask, we tell you to, if you don't show your work, can you debug?
No.
Yeah.
Can you?
No.
No.
I've had students make mistakes and there's nothing on their paper, and so I look at them and I just say, I don't know, you got it wrong. I hand it back. but I can debug when I see what they've done. So let's look at something that is your favorite topic, homework, and see how we can use debugging on this question, right? So the things we're going to focus on, remember foci is 2 focus, so this is a big one. Understand that a set of data. Look at your page here. Second page. That's all they mean. These points represent information. We collected it, we answered a question, and when it says it has distribution, do you see how we put dots in certain places? That's distribution.
So like how many people picking that day.
Excellent. You've done this before, haven't you? Good. And then this one is tricky. Summarize and describe distributions. We won't focus on that as much because before we describe and summarize anything, we want to debug and make sure we have the right information. So we can work on the summarizing maybe tomorrow. All right? So let's look at the situation here. All right. So the first thing we have to do is make sure that we know how to read a graph. Right? So what text feature do you see that helps us know what this graph is about, Jaking?
Number.
That is a text feature. Okay, good. So there's a graphic. What other text feature?
It's a graph to how much people depend on hours spent on homework per week.
And anytime we put writing on our graphic, we call that a label. Remember the importance of labels in math and science especially? All right, so our question or our information says that this dot plot, dots, and a plot is just where you put it, shows the number of hours per week that these 25 students reported doing on homework. I am going to say that I'm a little jealous of this classroom teacher because it looks like they do a little more homework, right? So, what are we going to think about with this? Let's see. We have to answer a question about the number of hours that this group of students spends. For each one, what is the important thing that we do? Not just the math we do, but we can explain your reasoning. Can you highlight explain your reasoning? Explain your reasoning. Excellent. Thank you for sharing. And then can I bring you back to this idea of debugging?
Totally.
Thank you. This is something really important for those of you who are a little shy in math class. When you explain something, that is often a time where debugging can happen because as you're saying something, sometimes you say, wait, that doesn't sound right. I know that happens in writing, but we don't do that often enough in math. And sometimes when we explain what we're doing, we have to explain, which means it's in our brain, and then we look at it and we say, oh wait, what I'm saying doesn't match what I wrote down. So again, explaining your reasoning is huge with debugging because when we hear what we want to see and then it's not there, that gives us a clue of where we should focus. Does that make sense? Good. And I love that because this is a good strategy for you then, right? Good. Let's see what else we have to do with 6 hours per week. Well, why don't we start by looking at 6 hours, all right? How many dots are there for 6 hours? Three. So do you think that describes a bunch of the students in there?
No.
Why not? Wait, before I ask you that, take a minute, just take 30 seconds in your head so everybody gets a chance to look at it. Maybe you're looking at the other dots as well as the 6. So I'm going to count in my head to 17. Look at this and think, is 6 a good description of the numbers that this whole group spends? So before I call on any one person, take a look. So if you hear a classmate say most do 2 hours, and we're looking at that, what is a way that you would figure out if this makes sense? Annalise says most do 2 hours. How would you approach this to see if that makes sense? What action would you do?
See how many dots they have.
See how many dots they have.
Or how many people prefer that hour.
Okay, so now she said dots and he said people. Which one is right?
people.
They're both right because every dot represents a person, right? Oh, wait a second. You know, I don't know if the person who made this graph did the graph right. How can we see if there's any mistakes in making the graph? How many students are we talking about?
Yeah, you have to solve it by counting different persons from different columns of the hours.
If I look at this page, it says 25 students. We're talking about 25 students.
Yeah.
How do I know if the person, and I'm not going to lie, I didn't make the graph. Somebody else made it. And I feel bad because I put it on the slide and I didn't even do this debugging. How can I make sure that that is a good graph to talk about 25 students?
By
Does it make sense? Is it about 25? What is Daniel doing?
Counting the dots to make sure that there's the right total.
I counted 24.
So should we debug? Should we see if there's any bugs in the numbers?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
25.
You know what? One time my husband and I went to eat and we got oysters. And I don't know if you've ever had oysters, but they put them on a shell on a big plate. And they come in a dozen. I was so glad I was debugging because I went, it's like, honey, we've only got 11 oysters.
And a dozen's 12.
And we really liked them, so it was a good thing we debugged because we had to make sure that there wasn't a mistake to fix, and I want my oysters. Yes.
And to like not waste your money. Even.
Right, right. So I like that you said not wasting money. If you're ever using money, you do want to make sense if you go to the store that it makes sense that you got the right amount of change.
And so like you don't get scammed with of your money for food.
Excellent. Yes.
Because you, like, if you ask for 25 oysters, but like they only give you 11, and you paid like a lot of money for it.
Exactly. So debugging is a way to be careful. Now that we know there are for sure 25 people, and now that we know that it says most do 2 hours, how would you show somebody the mistake in that statement? Any idea?
Can you please repeat the question?
Yes, I can repeat the question. Thank you. So, do we agree that most do 2 hours or that most do not do 2 hours?
Most do not.
All right. So you saw something that made you say that. Can someone explain or show what you saw, what you did to review this? Was it hard to decide?
No.
So why don't you just, Daniel, how do we know that most students did not do 2 hours? There's 2 different ways I think you could figure it out.
And
Still waking up? Okay.
Because one has more than 2.
So the 1 hour has more whats?
Has more people than the 2 hours.
Okay. How did you see that? How did you find, when you're debugging, you're looking in like a microscope, how did you find that out?
Because on number 2, only 4 people did it, and on 1 hour, only 5 people did it.
Okay, so you counted 4 and then you counted 5. Was there,
I think it's because, just like you said, that she counted the dots, and you could also tell by just looking at them that there's 1 extra than 2 hours.
okay, so by looking, your mind recognizes numbers at that level. You know, birds can count to 3 too. You can actually see that there's 1 more. So if she's seeing that there's 1 more, is there another way to describe this line compared to that line? This line is?
Greater than
hour 2.
And because it's
2 hours.
bigger.
taller than. So sometimes debugging, it just jumps out at you, and sometimes you have to look carefully. It is not wrong to do debugging when your teachers are teaching. And you do that sometimes, don't you?
Yes.
I will say or write something, you'll say, wait, Ms. Frankowiak, that's not right. I think that we should keep this poster up because I think you're really good at this. Okay? Okay, good. Now, can we work on making sure that we do at least 3 hours of homework a week?
No.
Come on. 4 people. 4 people. people do 3 hours a week?
That's because that's
Three
not, like,
people.
Oh, three people. Are you reviewing my thinking?
Yes.
All right, you win. Thumbs up, middle, or down for the debugging. I'm going to say you are 10 thumbs up. Thumbs up, thumbs middle, thumbs down for this graph stuff. I'm going to say this. I think we need to do a few more.
Like this.
All right, but the important thing is we got this. So yay, we are good.
As you plan to frame, prompt, and highlight computational thinking within your lessons, consider the following questions. What are some strategies my students could use to solve the problems in this lesson? How might a CT strategy already be part of or add to those strategies? How might I recognize when I see my students using a CT strategy? How might I identify when it would be helpful to prompt a student to use CT?